In this video, we will talk about the rational root theorem. When you hear the word rational, it just means that it's a number that can be expressed as a fraction of two integers. For example, 3/4 is rational. 3 is rational because it's just 3/1. And the rational root theorem basically just generates a list of all possible rational roots a polynomial expression can have. And if none of those roots are valid solutions, then you can conclude that the polynomial has no rational roots, which is, by the way, different from saying it has no real solutions, because a polynomial can have like square root 2 as a solution, but root 2 is not rational. So let's talk about how to use the rational root theorem. So the list that the rational root theorem generates is given by the plus or minus, and then you're going to list all the factors of the constant over all the factors of your leading coefficient. For example, let's consider the polynomial x cubed minus 2x squared plus 12x plus 9. The rational root theorem tells us that if this polynomial has rational roots, then it will be plus or minus, and now the factors of our constant is 9, so 1, 3, and 9 over the factors of a leading coefficient, which is just 1. And so that means our possible rational roots are plus or minus 1, plus or minus 3, and plus or minus 9. So now let's apply the rational root theorem. Suppose we're asked to factor x cubed minus 2x squared minus 5x plus 6 completely. So because factoring by grouping doesn't work, we need to use the rational root theorem to determine possible roots. Once we determine one root, then we can use synthetic division to find out the other roots. So first, let's find out what these possible rational roots may be, if there are any. So factors of 6, which is the constant, are 1, 2, 3, and 6. And the leading coefficient of this polynomial is just 1. That means our roots are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And so what it means for these values to be a root is that if you plug it in here, you should get 0, or you should have no remainder. So let's use synthetic division to test. So let's put our coefficients, and let's say we're testing 1 is a root. If 1 is a root, that means we just put 1 here. And the reason for this is if 1 is a root, that means our factor is x minus 1, and we have to negate it, which gets us back to 1. So drop the 1 and then multiply and add, and then multiply and add. And now look, because we got a 0 remainder, that means x minus 1 divides cleanly into x cubed minus 2x squared minus 5x plus 6, which means that x minus 1, or 1, is a rational root. And that means we have x minus 1, and here's the other divisor, and it's x cubed divided by a linear term, so we have x squared. X squared minus x minus 6. And here's our factorization. But we're not done, because we need to factor completely. This can be further factored. And this factors into x minus 3, x plus 2. And now we're done. We have factored it completely using the rational root theorem and synthetic division. So now let's practice again. 2x to the 4th plus 9x cubed minus x squared plus 18x minus 10. And we're asked to factor it completely. So once again, factoring by grouping doesn't work, so we need the rational root theorem. And so remember the plus or minus or factors of the constant over factors of the leading coefficient. Factors of the constant is 10, so 1, 2, 5, and 10. And our leading coefficient is 2, which has factors 1 and 2. This means our possible list of rational roots are plus or minus 1/2, plus or minus 1, plus or minus 2, plus or minus 5 over 2, plus or minus 5, plus or minus 10. So let's use synthetic division. 2, 9, -1, 18, -10. Let's see if 1 is a root. 1 times 2 is 2, 11, 11, 10. And now we see here that we don't need to complete it because we see that you're going to get a remainder by this step. But let's complete it anyway, 28. And you get a remainder of 18, sorry. So this is not a root. Let's try 2. 4, 13, 15. And we can already, sorry, not 18. 2 times 2 is 4, 13, 26. And we see this is going to grow way out of control, so 2 is obviously not a root. Let's try -5. 2 times -5 is -10. -10 plus 9 is -1. -1 times -5 is just +5. 4, -20, -2, +10, so which gets us 0. And so we have a 0 remainder, meaning -5 is indeed a root. And so really the key here is just using the rational root theorem to generate a list and then just testing out the roots and see which ones fit. So now we have x plus 5 times, and now we have x fourth divided by x, so we have 2x cubed minus x squared plus 4x minus 2. And let me erase this. And now, if you don't know how to factor this, you can use the rational root theorem again to get a quadratic that you might be able to factor. But we notice that this can actually be factored by grouping. Let's group these two and these two. In the first, we factor out an x squared to get 2x minus 1. And then here we'll factor out a positive 2. 2x minus 1. And now we can rewrite this as x squared plus 2 over 2x minus 1. And this whole thing is being multiplied by x plus 5. And because this quadratic term cannot be simplified further, we are done. We factored this fourth degree polynomial completely by using the rational root theorem.